Hello friends, how are you? Welcome to my YouTube channel Enlightened Mind. Today we will be calculating the electric field and electric field potential at the center of a uniformly charged hemisphere. So friends, let us consider that we have a hemisphere and hemisphere is of this shape. Okay, and our task is to find the electric field at the center of this hemisphere. So suppose this is a particular hemisphere, okay, and this is its center. So let us suppose that this is a particular segment of the hemisphere, okay, and this is the y-axis, right, and this is suppose is the x-axis, and this is your y-axis, and this is the center O. Okay, so let us consider that particular ring, okay, whose distance from the center from this particular point P is suppose small r, right, and from the center this point P is at a distance of capital R, which is the radius of this hemisphere. And this particular small circle of radius small r is suppose is in the form of a strip, and this strip has a particular thickness, okay, and that thickness suppose is dy. Suppose this thickness is your hemispherical strip thickness, and this is suppose is capital dr, d capital R, and suppose this makes an angle, capital R makes an angle at point P from the center, theta angle, okay. So this strip having a thickness dr would be making an angle, suppose this much, okay, and this angle is d theta. So you can easily find out if suppose this is a particular angle of this shape, and this is the thickness which is dr, and this angle is suppose is d theta, and this radius of course is this much, which is capital R. So d theta can be written as dr divided by capital R, okay, or in other words this dr can be written as r into d theta. That is one thing. So another thing is that you really need to calculate what is the area of this particular strip, okay, and the area of this particular strip suppose is ds can be written as 2 pi r, which is the circumference of this particular ring, small ring of radius r, and its thickness is dr, that we know, okay. So now you can put the value of small r. If this is theta and this is capital R, okay, if we'll consider that that particular point is M, okay, this point is small m, and from point P, O is a distance of capital R. So this small r, if this is the theta, here this theta, so small r can be written as capital R into sine theta, right? And then you can put this value of small r here, so that would be 2 pi capital R into sine theta, and del dr we already have calculated, which is capital R into d theta, okay. Now what is the electric field at the center, suppose O, because of this particular strip, so that particular electric field suppose is dE, okay, and that can be resolved into two components. If this is theta, so that angle should be theta, and this is the electric field along y-axis, and this is the electric field along x-axis, okay, right. And of course the electric field along x-axis would be cancelled out, because electric field along x-axis because of a point P, okay, is in this direction. Similarly, if suppose you consider another point, suppose Q, so electric field would be in this direction dE, and so electric field along x-axis would be cancelled out, okay, that would be cancelled out because of the opposite direction of these two electric fields, because of the component of P and Q, okay. So likewise, so in this case you can say that there is only electric field along the y-axis, so electric field along x-axis should be 0, okay, if you'll integrate, okay, but electric field along y-axis, which is the integration of electric field of dy, is non-zero. That is not zero. Okay, so that we have to really calculate. So that is very simple. So let us now consider how you will calculate the electric field along the y-axis. So suppose the electric field along y-axis would be the integration of d E y, and we already said that electric field along y-axis is small electric field along y-axis would be dE into sine theta, okay, into cos theta, sorry. If this is the electric field dE, then along y-axis that would be, because this is the theta and that is the base, so that would be dE into cos theta, right? So I'll put this value here. So dE along y-axis would be dE into cos theta. So you can put this value here, and that would be integration of dE into cos theta, right? So now comes what is the electric field along small electric field at point O because of the ring at point P. So that would be dE, and that dE we know can be written as 1 by 4 pi epsilon naught dq upon distance square. So here the electric field, I mean the distance of P from O is capital R. So you can put here capital R square, okay. And we already know that dq can be written as sigma into ds, which is the surface charge density into small area or surface area, okay. So you can put this value here to calculate the electric field. So that would be dE, which is 1 by 4 pi epsilon naught sigma into ds. ds we already have calculated, which is 2 pi capital R into sine theta into R into d theta, and that is divided by this much, which is R square, and then you have to integrate. So now for integration, if you'll put the limit, that limit is in the form of this theta. So when you are at this point, so angle would be 0, and when you come here, so angle this theta would increase to pi. So that would be from 0 to 2 pi by 2, sorry, 90. Okay, so that angle would be from 0 to 2 pi by 2, and so that can be written as you can take something out of this for these terms, okay. So many things would come out. So because this pi r, this r square would cancel out, so only you have 2 pi sigma. So that would be 2 pi into sigma. R is cancelled out, only sine theta would remain, okay. And also this cos theta is there, so you can write cos theta here, okay. So that would be upon 4 pi epsilon naught. Angle is from 0 to pi by 2. 2 pi already have come out, and sigma has come out, r square has cancelled out, sin theta and cos theta is remaining, then sin theta into cos theta and then d theta. That is the only terms which are remaining, okay. So that can be written in this fashion: 2 pi sigma divided by 4 pi epsilon naught, integration is from 0 to pi by 2, and if you put 2 here, so I'm multiplying dividing by 2 here, so that would be 2 sin theta into cos theta into d theta, okay. So that would be basically sin 2 theta. So that can be written as, you can cancel some of these terms, so 2 is cancel out and pi will also cancel out, so that would be sigma upon 4 epsilon naught from 0 to pi by 2, and that would be sin 2 theta and integration d theta. So just you have to integrate that one, so that would be sigma upon 4 epsilon naught, and when you will integrate, that would become cos 2 theta divided by 2, okay, and limit is from 0 to pi by 2. So you can put 2 here, so that would be sigma upon 4 epsilon naught, and 2 is of course coming here, so that would be cos 2 of pi by 2, that would be pi and then minus cos of 0. Cos pi is minus 1 and that is 1, so that become minus 2. So 2 would cancel out, so only sigma upon 4 epsilon naught would come. So that is the expression. I'm taking only the positive sign here and negative I'm neglecting. Okay, so that is the electric field along the y-axis. Of course, when you calculate the electric field along x-axis, that would be 0. Okay, it is very easy to calculate and to prove. Okay, so now our next task is to find the electric field, not the electric field but the electric potential because of this thing. And we know that the electric potential, which is the V, is nothing but dV. Okay, and of course angle would be 0 from 0 to this much, and we know that the electric potential would be 1 by 4 pi epsilon naught, of course dq upon r. Okay, and then you have to integrate that thing from 0 to pi by 2. Let us now calculate what it should come. So that would be, we know that this is nothing but sigma into ds, and which is nothing but sigma into 2 pi r, which is r, capital R, into sine theta, right, and r into d theta. So that would be nothing but 2 pi r square. Okay, 2 pi r square, then sigma sine theta and d theta, that should come out. Okay, and then you can put this value here, so that is nothing but dq. You can put this value here, so that would be from 0 to pi by 2. Okay, you can take 1 by 4 pi epsilon naught out of this integration sign, and r can also be taken out because this is also a constant, so that would be 2 pi r square. Okay, sigma into sine theta and d theta divided by r, so that 1 r would be cancelled out, so you can write 2 pi capital R, sigma you can take out, and 2 pi 4 pi epsilon naught is in the denominator, that is from 0 to pi by 2, and that is sine theta into d theta, right? So that is very simple. You can take some of these terms cancel, so that would become, you can write it down, and that would be r into sigma upon 2 epsilon naught, and when you integrate that one, that would become cos theta, and that would be from 0 to pi by 2, that is the limit. Okay, so that would become basically cos 90 is 0 and cos 0 is 1. Okay, so that would be r sigma 2 epsilon naught. So you can write simply sigma upon 2 epsilon naught into r. I'm neglecting the negative sign here. So that is how you can calculate the electric field intensity at the center of a hemisphere, and also its potential. Okay, so I hope this lecture would be liked by you, and if you like this lecture, you can click on the like button and subscribe my channel. Thank you for watching my video. Thank you very much.